Hi everyone, today I'm going to be showing you how you can use Amazon EMR to extract data from the Redfin data source and then transform the data, okay, and then load it inside Amazon S3 bucket, okay. Previously, I showed you how you can use Python to extract data from Redfin data source, load it in your raw data, and then transform it, and then load the transform data in your S3 bucket, after which we loaded it into Snowflake and then connected Power BI for visualization, okay? We orchestrated this process using Apache Airflow that is installed in Amazon EC2 instance, okay? If you have not watched this video, I encourage you to go and watch that, okay? I'll put the link to this video in the description below, okay? Now take note, for this project, we did it inside an Amazon EC2 instance. That was one machine, right? But remember in that video, for those of you that have watched it, you saw that the data was large, although it was in the gigabyte scale, okay? But in today's video, we want to do that same process, but then we would like to use Amazon EMR. So we will connect our Amazon EMR to the Redfin data source, okay? We extract the data, put it inside S3 bucket, okay? Then we'll grab that raw data from the S3 bucket, process it inside our Amazon EMR again. Then the transform data will load it back inside Amazon S3 bucket, okay? Now, we are going to be using Jupyter Notebook that is running in Amazon EMR to do this extraction, to write our code to do this extraction and do the transformation, okay? And then, and also inside this Amazon EMR, we are going to be installing or importing Apache Spark, okay? And then we will use the Pyspark API to write Pyspark code on our Jupyter Notebook to be able to do the extraction and transformation, okay? This is going to be interesting, guys. Are you guys ready for this? Very good, guys. So now, as you know, that the use of internet, IoT devices, sensors, social media, and so on have resulted in vast amount of data being generated every day. And for companies to process and derive insight from this data, or even train machine learning models, a big data technology or framework with distributed computing will need to be used. And also, we know that this data that is being processed by some of these companies are in the terabyte or the petabyte scale, okay? Now, examples of such distributed computing software frameworks are Apache Hadoop and Apache Spark, okay? Now, however, instead of you running these frameworks on your machine, you can preferably run them on the Amazon EMR, which comes with pre-installed big data frameworks, okay? It comes with these frameworks, okay? Now, let us understand what exactly is Amazon EMR. Amazon EMR, that you can call Amazon Elastic MapReduce. The EMR is Elastic MapReduce, but of course you can call it for short Amazon EMR, okay? This is a service offered by AWS, okay? It comes with pre-installed big data frameworks such as Apache Hadoop, Apache Spark, Presto, Flink, TensorFlow, and so on. I'm going to be showing you how you can provision the Amazon EMR in today's video, and also how we can use it to extract and process data, okay? But then let us take a look at what we have right here on this link. I'm going to be giving you this link in the description below, okay? it tells us that Amazon EMR is a managed cluster, platform that simplifies running big data frameworks such as Hadoop and Apache Spark. I just talked about that, to process and analyze vast amount of data. Okay, you want to analyze your data that is in the terabyte scale or petabyte scale, you can use Amazon EMR. Okay, now, and also this Amazon EMR can easily integrate with your different data stores or databases like the Amazon S3 and the Amazon DynamoDB. We will see the benefits we get if we using Amazon EMR shortly. Okay, now one thing I want to then talk about right here, let's take a look at the overview of Amazon EMR. Okay, when we talk about Amazon EMR, take note of one thing. When you are running your code on Amazon EC2, that is one machine right there. Or if you are running on your own personal laptop, that is one machine right there. Okay, but for us to explore Amazon EMR, then in that case, we need to provision clusters of machine. So we call them clusters of nodes. So that means each instance is a node. So what are we talking about right here? If you look at this, it says the central component of Amazon EMR is cluster. Okay, a cluster is a collection of Amazon EC2 instances. Okay, so that means when you provision a cluster of nodes, that means that you are provisioning for yourself multiple EC2 instances. Okay, so that means you want your code to be, or you want your data to be processed on multiple instances, multiple EC2 instances. So it's going to be a distributed computation that is going to be going on. Okay, you can see it says each instance in the cluster is called a node. Okay, now let me show you the node types that when you provision, you are going to be seeing in your EMR clusters. You have three. We have the primary node, which we also call the master node. You have the core node, and you have the task node. Okay, now this is what is happening, guys. So if you go on Amazon EMR and you provision, let's say you provision a cluster that has 6, or let's say you have 5 EC2s. Okay, so or 5 nodes. What happens right there is that one of them is going to be the master node. Okay, shortly I will tell you what the master node does. Okay, so one of them is going to be the master node, and the remaining 4 will be the core node. Okay, I didn't mention task node yet because task node is optional. You can see task nodes are optional. However, if I want to use task node, I could say I have 1 master node, I have 3 core nodes, and then I can make one of these. I can say the last one is the task node. Okay, now the question you ask yourself is, what is the difference between the master node, the core nodes, and the task nodes? Okay, now let's come back right at the primary node, which again is called the master node. It is the node that manages the cluster by running software components to coordinate the distribution of data and tasks among other nodes for processing. So basically what we are saying is that the master node or the primary node is what coordinates what is going on in this cluster. Okay, so it is the one that runs the software component that coordinate all these distributions, and also that coordinate distribution of data and also task. Okay, the primary node tracks the status of task and monitors the health of the cluster. Okay, that is what the master node does. It distributes data, right? It distributes tasks. It tells the different cores or the different nodes, this is your job, this is your job, this is your job, this is your job. Okay, and also it helps to track the status of the task that it has assigned to each of the nodes. Okay, Okay, look at something right here. It says every cluster has a primary node. Take note, every cluster. That means whenever you provision any EMR cluster, it will always have a primary node. And it's possible to create a single node cluster with only the primary node. So that means when you create an EMR cluster, you could decide that you only want a single node cluster. If it's a single node cluster, means that it's just going to be having only the master node. Okay. However, because you are dealing with big data right here, and you want your processes to be very efficient and quick, right? So in that case, you will want to assign, or you want to provision more nodes, right? They're core nodes, okay? And optionally, you could provision task node as well, okay? Now, what is core node? It says a node with software components that runs tasks and store data in the Hadoop distributed file system on your cluster. You can see that. So like I said, this core node is what runs the task. Take note. The core node is what runs the task. The master node is what is going to assign the task to each of those other nodes, and also helps to distribute data to all the other nodes. Okay. And also this core nodes store data. It stores data in the HDFS, Hadoop distributed file system, in your cluster. Okay, so look at this. It says multi-node clusters have at least one core node. What does that mean? Remember, I told you right here that you could decide to provision a single node cluster. If you provision a single node cluster, means that your cluster is only going to have the primary node, which is the master node. But then if you want a multi-node cluster, take for example, you want a 2-node cluster. That means one of them will be master node, then the second is going to be a core node. Okay, so that's why it says multi-node clusters have at least one core node. You should have at least one core node, okay? If you are going to be having a multi-node cluster, that is 2 or more nodes in your cluster. Now, what is task node? Task node is also pretty much like core node. It performs the task, but it does not store data in the HDFS. You can see it is a node with software component that runs only runs task and does not store data. Can you now say that is the difference between your core node and your task node? Okay, so that means I could decide to provision a 7-node cluster, 7-node cluster right here. I could say master node, that's going to be 1, and then I could say 1, 2, 3, 4 core nodes, right? That means that's a total of 5 nodes now, and then the remaining 2 is going to be the task node. Okay, because I'm provisioning 7-node cluster. But then take note that your task node, those 2 task nodes, they are not going to store data. So depending on your use case, that is what will determine if you want to use a task node or not. Okay, and then you can use this to do what? To run large, or to extract data from different sources, large data source, and also to process this data, this large data, for whatever thing you want to do, for business intelligence or for training machine learning models. Okay, now what do we stand to benefit when we run Amazon, or when we use Amazon EMR? Okay, one thing you need to know is that when you use Amazon EMR as a company, then there is no need for you to purchase and maintain any big data infrastructure on your company site. Okay, so that means you don't need to buy this big, servers and all of that, and then you need to start maintaining it and all of that. That's going to be a lot of work and a lot of expenses, right? So it helps you to save, to save some cost right there. We talk about cost saving. And also Amazon EMR pricing depends on the instance type that you also want to use. Okay, so depending, you're going to see by the time we want to provision it. Okay, and also one thing you need to realize is that this EMR, Amazon EMR, is on demand. Okay, so companies can save money by spinning up clusters and down without having to set up their own cluster. You don't have to set up your own Hadoop cluster on your premise or on your company site. Okay, you don't have to buy any server where you have to be maintaining it and all of that. So you can just create an account on Amazon and then provision your Amazon EMR, and then you can spin it up or spin it down depending on what you are trying to do. It's that easy. Okay, it helps you to save cost, and also you can easily integrate your Amazon EMR to other AWS services. Take for example, you can integrate it to your Amazon S3 bucket. You can integrate it to your Amazon DynamoDB or different data stores that you have. Okay, now if you are talking about scalability and flexibility, I'll give you the link to this in the description below, where you can read all these things right there. Okay, of course you can easily deploy it. In terms of scalability, you can see Amazon EMR provides flexibility to scale up or down as your computing needs change. So that means that you could even, let's say on Monday, you always have a very high workload. You always have a lot of data to process. On Tuesday, you only have limited number to process. That means you could configure your Amazon EMR to do auto scaling, in which case, whenever there is a large data set that is to be processed, it's going to spin up more clusters for you. And then whenever it gets to a time that it sees that the data is limited, is small, and then it scales down, it scales down the clusters for you, the number of clusters. You can see right here, it says you can resize your cluster to add instances for peak workloads and remove instances to control costs. You can see that now when peak loads subside, when peak workloads subside. So you can easily, work with the scalability and flexibility that AWS provides right there for you. Okay. And of course, in terms of reliability, right, and security, you can be rest assured that because Amazon is the one that, that is running all this configuration, doing all these configurations and all of that for you, it's going to be reliable. Okay. Amazon EMR monitors nodes in your cluster and automatically terminates and replaces an instance in case of failure. You can see that all this has been put in place by default for you guys. Okay. Now, what about security? Amazon also ensures that your EMR is secure. Take for example, you can use the I am role. Take even just an example is in our video today, we are also going to be creating an I am role that we are going to give permissions to be able to create EMR and do a whole lot of things. And also we are going to create Amazon VPC also today. So all these different features helps to secure our Amazon EMR. We are going to be using the EC2 KPS. Okay, all this helps to secure your clusters. Okay, so I will give you the link to this page, so you can also go through it, and also you can understand more what the Amazon EMR provides. Okay, so now the next thing we are going to be doing right now is we are going to be going into provisioning our EMR cluster, and then we are going to be extracting data and transforming the data. Okay, are you guys ready for that? Great, let's get going, guys. So now let us go to aws.com or aws.amazon.com. If you don't have an account yet, go ahead and sign up for an account. It's going to ask you for your credit card details and all of that. Okay, so now what we are going to do is that before we provision our EMR, our Amazon EMR, we need to create a user. Okay, we need to create a user. And why do we want to create a user? By the time we create the EMR and we want to use the Jupyter Notebook to run our code, we will not be able to do that if we don't have a user. Okay, and also we creating a user helps us to assign permission to that user, so that the user does not have the ultimate, access to everything on this account. Okay, and that is how it is being done in the industry. Okay, so the first thing you want to do right here, guys, is that you want to come to type I am, and then you can just open this in a new tab right there. So just come right there to users, create on this here. Let me see if I can zoom it. Okay, very good. I'll come to users, I'll create users, and then I'll come to create user. Okay, and then I'm going to give it a username. Take note, you are creating an I am user first. Okay, I would give it Redfin underscore EMR underscore user. Okay, and we want to give this both programmatic and console access. Okay, so I will check this, that provide user access to the AWS management console. Even though it's optional, I want to give it access to do that. Okay, and then I will say I want to create an I am user. I will check that, and then I'll give this a custom password. You could, if you want, you can say auto generate password and ask the user to create a new password on first login. But in this case, I will click on custom password, and then I'll put my password right there. Okay, I'll do a copy and paste right there. Then users must create a new password at next sign in. I would uncheck this because I already have a custom password, which is good already. Then I will say next. Now you can see it's asking me to set permissions. Okay, so now let me bring this here so we can see the whole page. So now set permissions, add user to a group. We don't have a group, so that's not what we are going to use. Then we'll just say attach. Let's come right here, attach policies directly. Okay, let us give this an administrator access. Okay, let us give it an administrator access. So come right here and check administrator. If you cannot see administrator on your own page, just type administrator. Okay, and then you can see administrator access. I would check that. Okay, now we have given it administrator access. Let us click next, and then let's create a user. So this will create a user for us. Now when you create the user, you can download the CSV so that you can remember the name of the user and also the password that you generated. So I'll click on this download CSV. I'll click that. You can see it has downloaded in my downloads folder. Very good, very good. So now that we have created this, now what I want us to then do is to create access and secret access key. We might need this down the line. Okay, let us click this return to users list. You can see this is the user that we just created, guys. Then I'll click this. When I click that, you can see that we have the administrator access right here. Okay, so now what I can then do is that I can come to security credentials. Remember, I'm inside this user. I'll come to security credentials. I will come right here to access keys. I will say create access key. When you create access key, to do that, then you will come right here, use case, command line interface. I will check this. I hope you guys are getting this right here, guys. And then I'll come to I understand. I'll check that. I'll click next. Okay, I don't need to put a tag. Then I'll say create access key. Very good. Now you can see that we have created our access key and our secret access key. Okay, now so that you don't lose this, just download this CSV, because if you lose this, then you will have to recreate it again. Okay, I hope you guys get that now. So I will download this CSV right here. I'll download. Now I've downloaded that right away. Okay, now it is in my downloads folder. I will go and check that in my other screen to make sure that it is there. Okay, it is there. Let me show you briefly what the credentials is. Let me open that. You can see that we have the username, the password, and a link wherein we can log in again. So what we are going to do right now, guys, is that we are going to log out of this account that we have right now, because this is the root account, so that we can then sign in with the new user account that we just created, and then we can continue with the project. Okay, so I'll come right here and I'll say sign out. I've clicked sign out. I close this tab. Very good. Now we have done that. I can even close this tab, and then I can come to this Excel, to this CSV. You can see that I have my username and my password, my link right here. Take note, I'm going to delete this user after this, so you won't be able to log in into this. Okay, so this will not be useful for you, so you have to create yours. Okay, so I will copy this HTTPS link right there. I'll bring it right here, and then I'll put it here. I'll press enter, and then you see that it takes me right here. It already populates my account ID for me right here. Okay, and then I can come right here, copy my username. Okay, and then I can also copy my password. I put right there, then I sign in. Very good, guys. Very good, guys. Now you can see that we have signed in. Very good. Remember that this is what we are trying to do, guys. Let me bring it right here for you guys again. Remember that what we are trying to do is we want to provision our Amazon EMR, and then we are going to get our Jupyter Notebook, install Apache Spark on it, and run Pyspark code to be able to extract data from the Redfin data source, transform it, right, so that our data, both the raw file and the transform data, can be in our S3 bucket. Okay, so because of that, what I'm going to be doing right now is I'm going to be creating our S3 bucket. Now, since we've already logged into our new user account, right, so let us create our S3 bucket. We are going to have two S3 buckets. One of them is going to contain the raw file, and the second one is going to contain the transformed data. Second one is going to contain the transformed data. Okay, now let us create our S3 bucket. So you come right here. If you are not seeing your own S3, if you are not seeing S3 bucket in your recently visited page, you can just type S3, and then you can maybe right click and open a new tab, and then I'll come right here. I will do create buckets, and then I'll put the name of my bucket. Remember that your bucket name needs to be unique. Okay, give it a unique name. So if you want to use this name I'm using, then you can maybe just change this last 3 characters here to, maybe your initials or something. Okay, and also take note that, again, let me quickly show you something right here, that you can see what we have right here in this file right here. You can now see that because we are signed in as a user on this account, that's why you see Redfin _EMR _user at this account number. You can see you should be seeing something of such, something similar to this. Okay, and also if you want to create your S3 bucket, make sure that your S3 bucket is in the region that you actually want. Okay, close to you. So wherever you are, if you're in Africa, or you are in India, or any part of Asia, or you're in the US, or any part of the US, make sure you are using the AWS region that is close to you. Okay, now this is my bucket name, which needs to be unique globally. Put in your AWS region, and then every other thing as you see it right here, okay, needs to be just leave it this way. You can see, make sure that you also have yours like this, and then do create bucket. Okay, so this is where we're going to store our raw data. Okay, let us create another one where we are going to be storing the transformed data. Okay, we are going to do create bucket again, and then we'll give it this name, and then make sure you're in the region that you want. Okay, and then every other thing should be the same as you see right here. Okay, then do create bucket. Okay, very good, guys, very good, guys. Now I hope you guys are getting this right here, guys. If you are finding these videos valuable, go ahead right now. If you have not subscribed to my channel, go ahead right now and subscribe to my channel and click on the bell, okay, so that you can be notified whenever we release any of our videos. Also, don't forget to click that like button. That is very important, guys. This also helps the YouTube algorithm to rank us higher, okay? And also, if you have any comment, put it in the comment section below, okay? If you have any question or you have any request, whatever kind of video you want us to make for you, put that in the comment section below, okay? Now I hope you guys get that. Very good. Now that we have our S3 buckets, the next thing I would like us to do is to create a VPC, okay? Because I want the EMR to run in a particular VPC. So I will type VPC right here, and then I'll open a new tab. Let's create our VPC. So now if you are here, just do create VPC, okay, and make sure that this is checked, VPC and more, okay, and then let us give it a name. This is an auto-generated name, but we can give it a name that we want. So I'm going to do a copy and paste of the name that I want to give it. When I put this name right here, see what is going on right here, okay? This is being updated. You can see right now the name is project. That's why you see project dash VPC, okay? So now I'm going to change the name to Redfin underscore EMR. You can see the name changed to Redfin underscore EMR dash VPC, okay? Now let us go down, and then our availability zone, let us leave it as 2. Our public number of public subnets, let us select 2. Okay, just click that. If you click, it's going to turn to gray as you can see. And then our number of private subnets, let us put it to 0. Okay, and let us leave every other thing the way it is. Our VPC endpoints to be S3 gateway. You can see as we did that, all this got updated. Our subnets, we have 2 subnets, right? And then we have this route table, you know, or it automatically create a route table for us. And then we have our network connections right here. All those are updated, okay? Now the next thing you just need to do is to click, leave every other thing and just do create VPC. You can see what is going on right now. It already creates the VPC for us, right? And remember the name we gave to our VPC, Redfin underscore EMR, okay? Very good, guys. Very good, guys. I hope you guys are getting this, okay? Now, the next thing we now want to do is we want to create our cluster, okay? Let us be on this page and then type in EMR. Then open this in a new tab, okay? We want to provision our cluster. You can see in my case, I have a lot of different clusters that I've run and terminated and all of that, okay? So the same thing we are going to be doing today. We are going to be provisioning our cluster and running, doing extraction and transformation. And then we are going to terminate our cluster when we are done with this project, okay? Guys, take note that at the end of this project, whenever you are done, make sure you terminate all whatever you have provisioned, your S3 buckets, your EMR, if you are not using them anymore, okay? All right, you can also terminate the VPC as well, okay, if you are not going to be using it anymore. So now you can come right here to create cluster. I'll click cluster, and then I will give it a name, okay? I'll give it a cluster name. This is what I'm giving it. Okay, now you can select which Amazon EMR release. Okay, you can see it says a release contains a set of applications which can be installed on your cluster. Remember what we said as part of the benefits of this Amazon EMR. It comes pre-installed with pre-configured with the big data framework that you want to use. Okay, so instead of you buying hardwares and all of that in your company, right, you don't have to do that. You can just use Amazon EMR to do that. Okay, you can just use Amazon EMR to process your big data, because this also helps to save you a lot of this. It saves your system admin time, right? So your system admin does not have to spend so much time configuring servers, installing softwares, debugging issues, and all of that. Okay, so when you provision this, it comes with your selected application that you want to be installed on your cluster. Okay, so in the case of this, now I will click this drop down and then I will say, okay, I want this latest EMR release. I'll select that, and then I would say I want to work with Spark. Remember, we want to work with Spark today. Okay, but if you want core Hadoop, if you want to work with Hadoop, you can select that. You can see when you click this, it already pre-selects the applications that are going to be installed in this cluster. If you want Flink, you select Flink. You can see it already pre-select this. HBase, Presto, you see Trino, or if you want custom AWS, right? I mean, if you want custom application, let's say you want specific ones that you want in your cluster, then you can check them right here, which is basically what we are also going to be doing today. But first of all, let us click this Spark. You can see when we click Spark, it checks this for Spark 3.4.1 and also Zeppelin. You can see that. However, because I told you guys that today also we are going to be having Jupyter Notebook in our EMR, okay? So because of that, we need to select Jupyter Enterprise Gateway, because if you don't select that, then you will not be able to attach the Jupyter Notebook to your Amazon EMR cluster. Okay, so because of that, we are going to select this right here. Okay, I hope you guys are getting that right now. Okay, so now the next thing is, you can see that when we selected this, then it switched to custom applications for us, application bundle, and that is because we selected something that was not selected in this Apache Spark. You see, when you're in Apache Spark, Jupyter Enterprise Gateway is not selected, but if I select it now, then it knows that, oh, this is a custom application bundle you are trying to request, okay, that you want to be installed in your AWS EMR. Okay, so now let's go down, let's leave all these the way they are, and then in this case we are going to be choosing instance groups. So right here we are going to be selecting what instances that we want. Remember, I was telling you previously that there are different instance types that you could select based on your workload. Okay, so for a primary instance, okay, that's the primary node, that's the master node, you can select what you want, the core node, and then the task node. Okay, right here. Okay, so if there is another one that is called instance fleet, it says choose any combination of instance types within each node group. Okay, but in this case we are going to be using this instance group, so I will just leave it this way, M5 extra large. But if you want other ones, you know, you can come right here and just, you know, select whatever thing that you want. Okay, oh, I mistakenly checked this when I clicked right here, so let us uncheck it. Okay, so uncheck this. Very good. So now let us just leave this M5 extra large the way it is. This comes with 16 GB of memory. That's okay, that's okay. Then let us choose our core node. Let us also leave this as our core node. Okay, M5 extra large comes with 16 GB, And then our task, remember, task is optional, like I showed you previously. So I can remove this right here. Okay, very good. Now remember one thing I also told you about using the Amazon EMR. I told you that you could set it to be auto scaling, right? So that whenever there is a peak workload, then it scales up. Whenever there is a limited workload, then it scales down. So I'm going to select this, use EMR managed scaling. That means that AWS is going to be doing that for you automatically. Okay, now for our minimum cluster size, we are going to select 3. And remember what I said, that if I select, let's say I select 3, that means that 1 is going to be master node, then 2 is going to be our core node. Okay, because remember that we have deleted task node right here. We don't want task, we only want the master, which is the primary, and the core node. Okay, so I want this to be my minimum. Okay, that means that whenever there is a limited workload, then it can go to the minimum, right? And it will just do 1 master node and 2 core node. Okay, so what is the maximum cluster size that I want? I could say 10. Okay, and then what is the maximum core nodes in this cluster? My maximum core nodes in this cluster, I could say 8. Okay, I could say 8. Okay, so what is this saying right here? This is saying right here that if my maximum core nodes in this cluster is 8, so that means that, let's say I have a very high workload, right? I can say, okay, my workload is very high, then scale it for me to have a maximum of 8 core nodes. So it's going to scale up to 8 core nodes. Then of course you're going to be having 1 master node, right? So we can do it like that. And then maximum on-demand instances, I can also put this to be 8 right here. Okay, very good, very good. So one thing you also need to know right here is that provisioning configuration is saying that set the size of your core instance group. So you want for us to just do this manually, we can just set this manually to be 2. Okay, you can just set this manually for a start to be 2. Remember that we said minimum is 3. So I can just say, okay, make my core to be 2, you know, when launched. Okay, Amazon EMR attempt to provision this capacity when you launch your cluster. You see that? So I can say, okay, when launched, just give me 2 of these. So if it gives me 2 of this core, then it's going to give me 1 master. So that still meets my minimum cluster size requirement. Okay, very good, guys. Now let us come here, our networking, our VPC. Remember that we just created a VPC, right? So let us come right here and we have created it already. So come to browse. This was the VPC that we created. We'll select this and then we'll say choose. You can see that immediately we chose that, it populates this with our with the subnet. Okay, now I hope you guys are getting this right now. Okay, now we can then come down and say manually terminate cluster. We don't want to manually terminate our cluster. We want to automatically terminate the cluster if our cluster is idle for specific number of hours. So I will select this. So you can, if you like, you can say after 4 hours. Okay, it's going back to manual. I know the reason. Just come right here, select, maybe just select 1 day first, and then you can come back and change. You can go back and change it later. Okay, so what this is saying is that if you want to, let's say you want to work on this project and you want to spend 4 or 5 hours on it, right? And you want to make sure that you terminate this EMR after specific number of hours. Okay, you can set it right there. You can say it after 10 hours, or you can say after say 9 hours, right? You can say after 9 hours. Okay, so now, but in my own case, I will just say after say I can say after 2 days. I can say after 2 days, that's 2 days, 1 hour. Okay, and the reason I'm doing so is because I'm creating a video right here. Okay, so I don't know when I'm going to finish with this project. Okay, while I'm working on this project, I may have some other errands that I need to run. Okay, so maybe it might take me 1 day or 2 days. So, and I don't want to be spinning up and spinning down each time. But take note that if you leave it still running, you are going to be accruing some expenses right there, some costs right there. So be wise in what you are doing. But because I'm making a video right here, I want to make sure that I have a good continuity. Okay, so that's why I will just say 2 days. Okay, however, by the time I'm done with everything, then I'm going to terminate it either myself or it terminates itself after these 2 days. Okay, so now check this use termination protection, make sure it's checked. Okay, let us come down right here. Now there is something that you see right here, guys. So it's a cluster logs. So all the logs that is being generated by this EMR needs to be saved somewhere in your S3 bucket. So if you want, you can create a particular S3 bucket for this case and then browse to that S3 bucket so that you can put it right here. If I say browse, you can see I can select whichever one I want. But in this case, you can see that I've not created an S3 bucket where I want to save the logs, but I will let Amazon AWS create it for me. Okay, so and this is what is going to create, because if you come to my S3 bucket right here, guys, you can see if I refresh this page, you can see that I only have 4 S3 buckets right here. Okay, but AWS is going to create this for me, and this is where all the logs from this EMR are going to be saved. Okay, very good, guys, very good, guys. So now I will come right here. Okay, I will come right here and I will create an Amazon EC2 key pair for SSH to the cluster, because if you want to SSH into this cluster, then you need to create a key pair. Although in today's video, I don't think we are going to be SSHing into our cluster, but I would like to create it so that you guys can see what we are doing. So to create an Amazon EC2 key pair right here, I'll just click create key pair. If you already have a key pair that is already created and you want to use already, you can just come right here, click your mouse right here, and then you can see for me I have different key pairs right here. Okay, so I can select whichever one I want to use, but I don't want to use any of these. Therefore I'll click create key pair. So when I click that, then it takes me right to this page so that I can then create a key pair. I'll give it this name. So I'm giving it this name right there. Then I'm leaving every other thing the way it is, but I will select .pem, okay, and then I will do create key pair. Okay, so it has created the key pair. So it's created one file right here inside this key pair, and then also it downloaded another key pair, a file, the .pem file, inside my downloads folder. Okay, if inside my downloads folder, that's the same thing it's going to do for you also. So now I can then come right here and look for that one that we just created. We can see we don't see it right here, but we can come right here and say browse, because it's not refreshed yet. So I can say browse. We should be able to see it here. Okay, we don't see it here yet, but we can click this refresh, let it refresh. Now we have refreshed. Now you can see it. This is it right here. So I will check it and then I will say choose. Now we have that right there. Okay, very good, guys. Now another thing we want to create is what we call Amazon EMR service role. Okay, you can choose an existing service role for EMR if you have that already, but I don't have, so I would say create a service role. So if I click that, you can see right here that it already selected the VPC that we created. Remember, we created VPC, so it already put the VPC and the subnet. Okay, so it's going to create that service role inside that VPC, right? You see, say let Amazon EMR create a new service role so that you can grant and restrict access to resources in other AWS services. Okay, so now let us select security group. When you click this, you should be able to see that VPC that you created before, because that VPC also comes with a default security group. Okay, so I will check this VPC right here. So when you check it, you can see that it has put that security group right there. Okay, very good, guys. Now another thing is what we call instance profile. Okay, create an instance profile. It says let Amazon EMR create a new instance profile so that you can specify a custom set of resources for it to have access in Amazon EMR. Okay, so in the case of this one, I don't have any instance profile, so I will, therefore I cannot choose existing instance profile. I will check this. Okay, look at something. Say the instance profile assigns a role to every EC2 instance in a cluster. Okay, so now we have this instance, then we'll say let us give it access to all S3 buckets. Okay, so we are saying all S3 buckets in this account with read and write access. Okay, now I hope you guys are getting this right now. Okay, very good. I think we are pretty much done. Again, guys, this service role would help to create and manage resources in our EMR. Okay, now I think we are pretty much done. Let us create cluster and see what happens. And usually creating cluster takes more than 7 minutes. So when we create this cluster and we see that everything is going well, what we will do is I will stop the video and come back to it whenever the cluster has been created. So let us create this cluster. Create cluster. You can see it's trying to create something right there. Let us go up. Is there any error? No error yet. Okay, you can see 0%. I will scroll up. You can see 67%. Okay, now it's working. You see, say your cluster, remember this is the name we gave it, has been successfully created. So now it is created, but it's still starting up, it's still booting up. Okay, it's going to boot up, initialize, and every other installations that needs to be done on the cluster is going to be done. Okay, remember that it's going to provision for us the clusters that we have requested. Remember, we requested for a minimum of 3 nodes, right? And we selected our core node that manually on the launch of our cluster that it should be 2 core nodes. So that means we should be getting 2 core nodes and 1 master for a start, right? So this is going to be starting, it's going to be booting up and installing all the different softwares that needs to be installed. Okay, and this is going to take 7 minutes or more, sometimes takes 10 minutes and all of that. Okay, so I'm going to stop this video and then come back to this video. However, before I stop this video, if you have not subscribed to our channel, go ahead and subscribe right now. While this EMR is running, go and click that like button. Okay, and also subscribe to our channel. Also click on the notification bell so that you don't miss any of our videos. Also put your comment in the comment section below. While this is running, booting up, go ahead right now and put your comment or whatever question that you also might have. All right, guys, I'll see you when this cluster is provisioned. All right, see you guys later. Very good, guys. Now you guys can see that our EMR has been provisioned. Okay, you can see now it says waiting. Okay, now you can see that the elapsed time is basically 12 minutes right here. Okay, 11 minutes 59 seconds. That's 12 minutes. You can see that it takes some time. Okay, you should also be seeing such when you are provisioning yours. Now what is the next thing to do? Okay, remember that we want to extract data from Redfin, and I said we're going to be using Jupyter Notebook. Right now we've provisioned the EMR. Now we need to make our Jupyter Notebook to be running in that EMR. Okay, However, before you can be able to run the Jupyter Notebook, you need to create what we call Studio. Okay, you need to create what is called Studio. So if you come right here to this hamburger sign, you can just click that, and then let us look for studios. Okay, because it is inside the studio that we can then create our notebooks. Notebooks are called workspaces now in AWS. Okay, so I'll say studios. When I click that, and then let's see something. Let's see if we can see something on this getting started. It says set up. Let me see if I can make it bigger. Awesome. It says set up EMR Studios to help your team develop, visualize, and debug data engineering and data science applications in an integrated environment. Studio setup requires a few steps. Once configured, you'll be able to effectively manage access and control permissions. You can see that. Okay, it helps you to be able to what? To manage access and control permissions. Okay, look at something right here. It says create studio. It says create as many EMR studios for your team as you need to access features, control clusters, manage templates, and all of that. Okay, so we need to create this studio. Okay, and then inside which we are going to create our Jupyter Notebook, which is going to be workspaces. Okay, so let us click create studio. Now let us give our studio a name. I'm going to give it this name, Redfin Data Team. I will paste it right here. It says provide a unique name for your EMR studio. This will be the name your studio team sees when they log in. Okay, now that we have that, it says after you have created a studio, you will then be able to add users to it and refine permissions. That's interesting, guys. So now in my case, I'll leave the description and the tags. Now I need to select which VPC. Remember, we created VPC previously. Okay, so you just need to make sure that you know what's the alphanumeric code for the VPC. You can come to your VPC page. Remember, we have not closed this, but if you have closed it, you can just type VPC and then go there. Okay, let us look at our VPC right here. You can see where we created our VPC. You can see the alphanumeric code right here. The last digit is D608. If we come here, you can see I have D608. I will just select that. If you don't have yours, just go to your VPC, just type VPC and go to your different VPC and be sure that you have which one. You can see this one was what I had before. If I refresh, this is the one we just created, D608. That is this Redfin EMR VPC. Okay, remember we want to create the studio right now, and then let us check our subnets. Okay, so we can select, both subnets. We can select both subnets because we had two subnets that were created as part of our VPC. Okay, then I can come here and say default security group. I can select that. Then I can just leave it this way. I want to enable clusters, endpoint, and Git repository, although we are not using Git repository in this video. Okay, and then the next thing we are going to be doing right now is that we are going to come down. All these are optional. I will leave it that way. I am service role. Now remember, we created the service role the last time when we were creating our EMR. Okay, now the service role, usually it has a timestamp of when you were creating it. Okay, like this one was 2023 October 23, and the timestamp 11 o'clock 42 seconds. Okay, so this is the service role that we just created. Okay, so guys, we need workspace storage. What is this workspace storage? This is where your Jupyter Notebook that you are going to be using in this studio will be saved. Okay, now in the case of this one, if I come to browse S3, I don't want to create I don't want to use any of this S3 bucket. I'm going to create another S3 bucket for this. By the way, if you remember that when we were selecting the EMR, when we are creating the EMR, we asked EMR to automatically create an S3 bucket where those logs for the EMR is going to be saved. You can see now it has saved it right now. If I come to my S3 bucket, if I refresh, remember before it was only this 4. If I refresh this now, we should see it. Now you can see it right here, guys. This is where our logs will be saving. Okay. However, for the Jupyter notebook that we are talking about right now, let us go and create another S3 bucket where we want to be saving the Jupyter notebook that we are going to be using here. So I'll say create bucket. I'll give it this name. Make sure it's in the region you want, and then I will leave every other thing the way they are. I will say create buckets. I'll click create buckets. Oh, something is wrong. Oh, it says that bucket name contains invalid character. It doesn't want underscore, so I'll use dash, and then I will say create buckets. You can see bucket has been successfully created. I'll go back to my studio, and then I can refresh. You can see right here, guys, that this is the one we just created. So I would select this, and then I will choose. So now I have chosen that my Jupyter notebook should be saved inside this workspace storage. Okay, and then I will click create studio. Okay, now you can see it's trying to create. It did not create. What's going on? So there is an error right here. It says the service role does not have permission to access this bucket. Remember, we just created this bucket. So our service role does not have access, does not have permission to access this bucket. So what we can do is, remember that we had created the service role. Remember, this is the service role we are talking about right here. This service role. Take note, the timestamp is 11:0042. So what we can do is we can go to our IAM. Let's go to our IAM page right there. I will open a new tab. Let us go and look for that service role, and let us give it S3 full permission and also administrative role, so that it can be able to have access to our S3 bucket. So we'll come to roles. And this is the role. You can remember 11:0042 that I just talked about. This is the service role that was created during our EMR, when we were provisioning our EMR. Okay, so I will select this, or better still, just click on it, and then you can come right to add permissions, say attach permissions. I can select administrator access, or you can search for it. I can also search for S3. This is Amazon S3 full access. I will check this. So now we are giving it administrator access and S3 full access. I will click add permissions. You see, it says policies have been successfully attached. I'll close this. You can see now administrator access, S3 full access. Very good, guys. I hope you guys are getting this. Again, guys, if you are new on this channel, go ahead right now and subscribe to our channel. Okay, and click on the bell so that you can be notified whenever we release any of our videos. Okay, now guys, let us come back right here. Now let us create studio again. Create studio. Let's see. Now you can see it's successfully created. I'll close this. Now you can see that we have created our studio. You can see this is our studio name. This is the creation time. It is authenticated by the IAM because we gave it access. Then this is the studio access URL. Very good, guys. Now I hope you guys are getting this. Okay, now that we have created our studio, now let us now create a Jupyter notebook. Okay, remember the Jupyter notebook is going to be inside this studio name, right? So that means all the Jupyter notebooks that we are going to be using are going to be inside this studio name, right? And we can give different users access to this. Okay, Now, if I click on this studio access URL, click on this, it opens a new tab, and then you can see that it comes to this workspace. And I just told you that workspace is basically our Jupyter notebook. So I'll click on create workspace. I'll click on that, and then I'll give my workspace a name. Okay, so that means you can have different workspaces inside this studio. Okay, so now I've given it this workspace, and take note that this workspace is basically we are going to be, you can see this S3 location. Like I said, that this is just telling you that this is the S3 bucket that our notebook is going to be stored. Okay, so we are creating our workspace right here, and then leave this description, leave this S3 location the way it is, because this is where our Jupyter notebook is going to be stored. And then all these are the networks that we have created, or that we have assigned. We created the VPC before, right? And then these are the VPCs that we have assigned to our studio. Okay, and our studio also have created these security groups, these default security groups right here. So let us do create workspace. Let us click that. Now it's running. You can see now, guys, that it says successfully created workspace, Redfin EMR workspace. Now you can see right here. Okay, there is an error. It says unable to launch workspace. This workspace. Make sure your browser allows pop-ups for this site. So that means that we are not able to eventually open our Jupyter notebook because we have a pop-up, because we need to allow pop-ups, right? So I'll come right to this pop-up right here that was blocked because I'm blocking pop-ups on my browser. So I'll click this, and I will say always allow pop-ups and redirect this. So just click that. If I say done, that should be good. That should be good. What I can then do now is I can click on this workspace name, and then this is going to open up my Jupyter notebook for me. So just make sure that you disable your pop-up blocker. Okay, just disable it if you want to be able to open it, or just give it permission to be able to allow pop-ups. So I'm going to click on this right now. You can see I've clicked on it, and now you can see, guys, that it is opening up Jupyter notebook for me, guys. Very good, very good. You can see Jupyter Lab is being open right now. Very good, guys. I hope you guys are getting it. And you can see the name of the workspace that we created, Redfin-EMR-workspace.ipynb. That's the Jupyter notebook. You can see that, guys. You can see now we have our Jupyter notebook. However, we still need to assign this to a particular EMR, a particular cluster that we want. Okay, even though we have created a studio, remember what we did before was to create a studio, and then we created a workspace, and basically your workspace is your Jupyter Lab, right? So now, your Jupyter Lab inside the studio, but then we need to attach this notebook to the actual EMR that we want. So if you come right here to this EMR compute, I will click this. Okay, and then make sure you are selecting EMR cluster on EC2, and then I'll come right here. You can see this is our cluster that we had created before. I will select this. So now I want to attach this notebook right to the EMR. So I will click attach. This runtime, just leave it that way, and then I will attach. Okay, now it's going to attach right now. And if you remember what I told you previously when we were configuring, or when we were provisioning our EMR, right, we selected Jupyter Gateway or something. What was that called again? Jupyter Enterprise Gateway. Okay, remember we selected that. If we did not install that in our EMR, then we wouldn't have been able to attach our Jupyter Lab or Jupyter Notebook to this EMR. So if you come right here to this compute again, let us see if it is attached. You can see now it says cluster is attached to the workspace. You can see it is attached now. This Jupyter Notebook is inside this this cluster, this EMR cluster. Very good, guys. I hope you guys are getting it. Okay, so now we have been able to create a Jupyter Notebook or a Jupyter Lab Notebook on top of our existing cluster. Okay, and also remember that we needed to disable our pop-up blocker for this particular site for us to be able to do that. Okay, very good, guys. Now the next thing now we want to now do is that we want to work on extracting data from the Redfin data center and then do some transformation. Okay, so for us to do that, let's first of all come right here to this file browser, click that. Now you can see this is our Jupyter Notebook. As we know, we have attached it to our EMR, right? Then I will double click this. When I double click, you can see it's asking me to select the kernel. Okay, so I'm going to choose Pyspark right here, and then I will say select. So now you can see our cluster is attached. If I put my cursor here, you can see my cluster name, right? And now you can see this is Pyspark right here. Very good, guys. I hope you guys get this right now. So now if you go back to our PowerPoint, if you come back to our PowerPoint, now you can see that we have provisioned Amazon EMR. We have also created our Jupyter Notebook, and we have attached it to our Amazon EMR cluster. Okay, we have created all the necessary S3 buckets. Okay, now what we have to do now is to install, to import Spark session in our notebook and then start writing Pyspark code to be able to extract data from the Redfin data center link. Okay, let us get that going, guys. Okay, so now let's go to this. Well, before we go to the Redfin link, let us import. I'm going to be doing some copy and pasting right here, guys. Let us do this import from pyspark.sql, import Spark session, and then pyspark.sql.functions import call. Okay, so if for you to run this, just press your shift enter. On my Windows, I press shift enter. I think it should be the same thing for Mac users as well. I think just give that a try. For me, I'm using Windows. I'll press shift enter. So if I press shift enter, you can see that execution has started. So it's starting Spark session. And then let me see if I can zoom this. Let me see if I can zoom it. Okay, very good. I think this is better. Okay, this is better. Now you can see that it is running. Okay, so some of the codes we are going to be running right here might take some time. Okay, so take note. What I'm going to be doing is that for anyone that is taking time, I'm going to pause the video, let it finish running, and then we come back to take a look at the result. That way we don't, make this video long unnecessarily. Okay, so now you can see this is still running because it has asterisk. Okay, so that means subsequently in this video, while I'm running this Jupyter Notebook, if there is anyone that is asterisk and is taking some time, I'm going to pause the video, let it run in the background, and then I will come back to the video while it is when it finished running. Okay, very good, guys. If you are liking this video, guys, if you like this video, if you find it valuable, go ahead and click that like button. Okay, and if you have not subscribed, subscribe right now and share these videos among your friends. Okay, all right, guys, this is running now. You can see it is in progress. Okay, but I will come back after it finishes the importation. See you later, guys. All right, guys, this has finished running. You can see now it says Spark session available as Spark. You see now it is available now. However, the first thing I would like us to do is to go and extract that data that we need. So if you go to redfin/news/data center, I will give you the link to this in the description below, and you can go in right there. For those of you that have watched my previous video where I showed you how to where we use Python to extract that data, you already know where the data is. Okay, so if you have not watched this video, I encourage you guys to go ahead and watch this video as well. Okay, we used Airflow to automate this process. Okay, so I will again come back right here, and then I'll use a bash command to extract this data. I will use a copy and paste right here. I will also give you this code. I'll give you all these things, the Jupyter notebook. I will give you this in my GitHub. Okay, so go ahead and fork my GitHub page where I have this code, or you can download it whatsoever way you want it. So what I'm doing right here is I'm doing %% bash because I want to run a bash command. Okay, so I'm using wget -o -http. So this is the link where we want to download our data. Where did we get this link from? This is the .gz. Okay, where did we get this zip that link from? If you come to this link right here, then you can come down to this city. Okay, so if you right click on this city, you can copy the link address. So depending on which of the data that you need, Redfin provides us this data at a national level, metro level, state level, county level, city, zip code, and neighborhood level. But we want to use city level. So if I right click this and I do copy link address, I can just show you that in a notepad right now. If I paste this, now you can see right here, guys, that this is the data we just downloaded right here. Okay, that we just copied the link. So it is this link that, let me close this, it is this link that you are going to put inside this your bash operator. Okay, now we are going to extract this data. So when we extract this data, and then we can then pipe it into our AWS S3 bucket. Remember, we have our AWS S3 bucket. We have this one right here, store raw data YML. Okay, so we are going to put AWS command. Okay, because remember that this is EMR, this is AWS service, and this is already pre-configured. The AWS CLI is already pre-configured on this system by AWS. Okay, and because of that, we just use the AWS command. So we say AWS S3 cp, that's copy, okay, dash S3 this is the path for our S3 bucket. Okay, and then you put a slash. What is the file name you want to call that file whenever we send it into this S3 bucket? We want to also call it this S3 market tracker this. Okay, we want to also call it this, and that is why we gave it this as well. Okay, so now let us run this. Take note, I'm going to be giving you all this in my GitHub. So press your shift enter, and now this is going to execute. Okay, I will give it some few seconds, let it execute. I will pause the video and come back again. Okay, very good, very good. This has run successfully. You can see last executed, and you can see all the data. We downloaded the data, you can see it right here, and then we pushed it into that S3 bucket. Okay, let us take a look. You can see it written to standard out, and then we piped it into to be copied into our S3 bucket. Okay, so if we go back to that S3 bucket, let's see, let us just refresh this page. Let's refresh that page and click on this store raw data. Let us click. Now you can see right here, guys, you can see that the size is 1.1 gigabyte. 1.1 gigabyte. We have been able to save to load this into our S3 bucket. Very good, guys, very good, guys. Now the next thing we want to do is we want to start our Spark session. Remember that our first line right here was to import our Spark session, okay? And now we know that our Spark session is available, okay? So now what we want to do is that we want to have Spark session.builder.app name. You can just give it an app name. So I can just say maybe, Redfin data analysis dot get or create, okay? So we are going to assign that a variable Spark. So I'm going to run this. You can see that that is executed. Very good. And then what we want to now do is that if you remember our PowerPoint again, we are running Jupyter Notebook, right? Inside our Amazon EMR, we have Apache Spark being installed, right? That's part of what part of the software that was installed in our Amazon EMR. And then now we are calling Pyspark API. Pyspark API, that's what we are using, to write our code right now. We extracted the data from Redfin into our S3 bucket, okay? That's the raw data file. Now we want to grab that data file inside that raw S3 bucket. We want to grab it back and then start to do some simple transformation, okay? Now let us close this and then let us do Redfin underscore data. Let's assign it a variable name. Remember, we have our Spark session right now, so I'll say spark.read.csv, and then I'll put the path of the file. Then I'll say header equals to true because we have a header for the data. Okay, for those of you that have watched my video right here, if you have not watched it, I encourage you to go and watch this. I showed you how the data looks like in a CSV. Okay, because in this video we converted that data into CSV and then we took a look at the different columns and how the data looks like. Okay, now then we want to say infer schema, okay, and then the separation is a tab delimited file, so we can then run this. Let us run this. So this also might take some few seconds to run. We would pause the video and then go and then whenever I finish running, we'll come back. Remember that we are running this on Amazon EMR with our clusters being provisioned. Okay, all right, see you when this finish running. So now you can see that this has finished running. We have our data right now. If you open this Spark job progress, you can see right here, guys, that all this has finished running. Let me see if I can bring it back so that you guys can see the full picture. Okay, very good. You can see complete, and then I can close this. Now we have our data. Okay, now if you want to see the first 3 rows of the data, you can just do redfin underscore data.show. Then you can put 3 right here. Remember, we are running Pyspark code right here now. This is not pandas, this is Pyspark. Okay, we have our Redfin data variable, and then we want to see the first 3 rows right here. If I run that, we should be able to see that. You can see it right here, guys. You can see it. Although, because this is not a big screen, because of that, we are not able to really see it very well. But don't worry, we are going to be seeing it very well later when we drop some of the columns. But at least this shows you that we have data in this. This shows that we have been able to extract the data. Okay, so let me make this smaller. Okay, this is good. This is good enough. Now let us go to the next thing right here. There is something also we call schema, print schema. If you want to check the schema of this data, we can say redfin underscore data.print schema, and then this is going to return to us the different columns. You can see how many columns we have. I think it's about 58 columns. You can see the different data types that each of these columns are. Remember that we infer schema, and then we can see all the different schema. You can see not labeled true, all these different things. We can see the data types that was inferred by the Spark session, by the Pyspark. Okay, very good. Now that we see that, I'm just trying to show you the different, types of analysis you could do right, or the different kind of line of code you could write to see whatever thing you are interested in. Okay. Now, what about if you are interested in seeing the column names? You want to see the column names. So you say redfin_data.columns. You can see these are the different column names. For those of you that are new in Pyspark, this is an opportunity for you to start getting introduced to Pyspark. We are writing Pyspark code right here. Okay. Now, what I want to do right here is that, what about if I don't want all these columns? Let's say you want to do some machine learning model, or you want to do some analysis, but you don't want to use all the columns, right? These are about 58 columns, but you want some specific columns to be used in this, your analysis. Okay. So what you can do is, so right here, take your data frame. This is our data frame. Then do dot select, and then put all the columns you are interested in a list. Okay. So now that we have that, we could select that, and then let's show that. Let's put dot show right here. Okay. So that means that we are saying that for out of all these columns, we only want to select these specific columns. Okay. And then let us show the data frame. Okay. Let us assign it to a different variable name, df_redfin. Let us enter. Remember, enter is shift enter. Okay. This might take some few time. Okay. Some few seconds or 1 or 2 minutes. Let us pause the video and come back when this is done. Okay. Okay, guys, this is done. Yeah, pretty much this takes, this was faster than I thought. You can see right here now, guys, that you can see we have period end column, period duration, city, state, property type, median sale, and every of these things right here up to this last, updated column. You can see right here, even though, it's still because of my screen size, you can still see that the columns got divided into 2 rows. Okay, that's fine. If you have a bigger screen, you should be able to see it very well. Okay. Now, one other thing that we can also do is that, what about if we want to check the total number of rows that we have right here? I can just do Redfin. Remember, this is our data frame now. I can then do dot count. This is also going to take some few minutes, so I will run it and then pause the video and come back. Usually dot count takes some time to run. Okay, let's come back when this is done. Now, very good, guys. Now you guys can see that we have 4.9 million rows right there. You can see. Okay, 4.9 million, right? 4.9 million rows. Okay. Now, what about if we want to count the number of nulls for each of those columns? Okay. So if I want to count the number of nulls, you see, count null values in each column. Okay. Now, in this case, I have to import what we call is null. So .sql, you say from pyspark.sql.functions, import is null. And what I'm doing right here is I'm using a list comprehension. I believe for those of you watching this video now, I believe you understand list comprehension already. Okay. So what I'm doing right here is I'm looping through this list, because df_redfin.columns is going to give you a list, right? And then if you loop through, okay, so for each column name, right, we are checking if there is null values, and then we are counting that null values, right? And then we are going to put all of that in a list, and that's why you have this list. That's why it's a list comprehension. And then we are going to print out that list. We are going to see the result right here. Okay, let us press shift enter and wait for some minutes or so for the result to be ready. Very good. Now, guys, you can see that we have some of those columns that some of those columns do not have null values, while some of them do have null values, right? But which columns have null values, which ones do not? Let us run this other code to display the results so that we can see which ones have null values, which ones do not. So what I'm doing right here is I'm enumerating these columns, right? Because this is going to give us a list. Then you enumerate the list. So we want to get access to this null count right here, right? Because when you get the index and you get the column name, right, from this list right here using this enumerate function, right, then the index that we get, the index for each of these columns, we can get the value of the null count from this that we got right here, okay, this null count, okay. So I would run this, and then we can see right here that the period end has 0 null values, city has 0 null values. You can see these different columns have their own null values. You can see right there, okay. Also, if you want to check the number of missing values or missing rows, if you want to check the total number of missing rows that we have in this data, you can also go ahead to run this. I will not run this right here because of our time, but what you should be seeing right here is that I'm doing this data frame.na.drop. So I'm saying drop the NA and then count. So that's going to be the remaining count, and then you can say the total count minus the remaining count. That should give you the number of missing rows, okay. So you can run that. Let me add more cells to this right here. You can just click this plus sign so you can add more empty cells, okay. Now you can run that. Take note, it's going to take some time to run. Like I said, this dot count usually takes some time, okay. Now what we can then do right there is that you can also run this function, right? Because when you get your remaining count, when you get your remaining counts here, if you want to see the value, you can just run this to know the remaining rows. That is, after you do a drop NA, you can then check the remaining count, okay. Very good right there, guys. Also, what about if we want to then drop NA? Remember that what we did right here is that we drop NA here and then we count, and then we'll assign that count to this variable, but we have not actually dropped the NA entirely in terms of assigning it to a new data frame or to remove the NA in place, okay. So that's what we want to do right now. I want to actually remove all the NA now, and then I can count the number of remaining rows. So what that means is that what number you're going to get here should be the same number you are going to get right here in this cell, okay. But I don't want to run these two cells to save our time, so let me run this one right here. Let me just run this one right here. So right now what we are doing is we are actually indeed dropping. So this is going to run for some time, and then I'll come back when it finished running, and then we go from there, okay. Now, very good, guys. Now you can see that we dropped NA right here, and then we counted the number of rows that are left. You can see now we have 4.4, right? Whereas previously we had 4.9 when we had not removed NA. Okay, very good, guys. Now that we have that, what I would like us to do is now let us validate if we still have NA or not. Let us rerun this code right here. We want to count null values in each column to confirm if we have removed all NA. Okay, so let us just rerun. If this runs successfully, we should have a list like this, but it should all be zeros. That is, there should be no null values. This will take some time, okay, and then I'll come back when it's finished running. Very good. Now you can see that this has finished running, and we have all zeros right here, meaning all our columns have 0 null values, no NA. Okay, very good. Let us go ahead to save this. Let's make sure we save it. So I'll click on that save. Okay, and the saving, okay, now it is saved. I believe it is saved. Okay, and then one thing I wanted to point out right here is that you will notice that right here imported is null, right? So I could have as well import all the functions from the very first cell. I could have as well just come to the first row right here and just say from pyspark.sql.functions import asterisk, right? So that would have imported all the functions for me, okay? Or I could even as well imported all the different functions right here, like call, I can say comma, then I can say is null, and all other functions, but I don't want to import everything on this first cell so that we can be able to import them on the necessary cell so that you guys can see what I am doing, okay? However, in the real life, you would have imported all the necessary functions from the first cell, okay? But in this case, I just wanted us to see how those different, libraries are imported, okay, all those different methods as the case may be, and that all those different functions, okay, and that's why I'm importing them one after the other, okay. So now let us do this right here also. Let us also from the sql.functions, let us import year and month. What am I trying to do right here? If you come back to our data set right here, to our data frame, you can see we have period end, right? And this period end is dates. You have the year, month, and the day, okay? So I want to grab the year, and I also want to grab the month, okay? And that's what I want us to do right here, and that's why I'm importing year and month, okay? And so what I'm doing right here is our data frame dot with column, okay? So with column is going to take this first argument, which is going to be the new column that you want to create, the name of the new column you want to create. It could be the existing column, and it could also be a new column you want to create. But in this case, I want to create a new column. I will say period underscore end underscore year. Then I will say year. Remember that we have imported this right here, comma, bracket call, and we have imported call from our first cell, and then this column. This column is the period end column, which is the dates object, where we have the year, the month, and the day, okay? So in this case, I want to extract the year, and then I want to put it in this column, okay? So that is what we want to do. We could also just do that also we could also put this right here and do that for month, okay? So that means after we got that, we want to do it for month also. Period end month is the new column we want to create, okay, from this same column, okay? And then we can just run this, okay? That has finished running. Now that we have finished running there, what I can do is I can decide to drop the period end column. I don't need it anymore. So depending on your use case, let's say you are doing some machine learning training and you don't want to use this period end column, the only column you probably needed is end this year column and this month column, okay? So that means you can drop this. So we are going to use data frame dot drop. So put the column name, and then this last updated, I don't need it. I also want to drop that. So I will run that. That has also dropped, okay? So now what I also want to do is that if you look at what might be happening, maybe I should just show you first so that you have an idea of what is going on. Let me show you how the data frame looks like now. This is going to run, it's going to take maybe 1 or 2 minutes or so, and then I will come back, and then I would, oh, it has finished running. Okay, very good, very good. It ran successfully. Okay, this one right here now, you can see that now we don't have the period end anymore. We only add the period duration. And then if you look at this last column right now, period end date and the period end year, which we just created right here, end month, and end year. Okay, you can see that we have that right now. You can see that this period end month, it is 6, and then period end year, it is 2019. So now what about if we want to map all these months that are in integer? Let us map it to the actual month, the name of the month. So 6 should be June, right? 4 should be April. What about if we want to do that? How do we do that? So let me show you that right here. Okay, so there might be different ways for you to do it, but this is one way. Okay, so from these functions again, let us import when. Okay, so what we can then do is our data frame dot with column. So this is the column, right? With column, take note, this is the same column which we have before. So that means that we are not creating a new column right here, but we are just updating the column. So that means anywhere we say 1, anywhere the period end column is equals to 1, make it January. Anywhere is equals to 2, make it February, and so on. Otherwise, if it is not having 1 to 12, either 1 or 2 or 3 up to 12 or 12, then we can say otherwise put unknown. Okay, so now if we run this right now, very good, we have executed that. And then what we can then do is we can say, okay, let us take a look at the data.show. So let's wait, maybe this also will run quickly as we run this one. This one ran within seconds. Okay, very good, it has run. Now you can see right there, guys, now that the first is June, second is April, then June. Just like right here, June is 6, April, right, that's 4, and then June 6. That's the same thing that we got right here, June, April, June. Very good. Now you guys can see how we are able to do some transformation of this data set in our EMR using Pyspark that we are running on a Jupyter notebook. Okay, again guys, if you are new on this channel, go right now and subscribe to our channel and click on the bell so that you can be notified whenever we release any of our videos. And also, if you have any question for us, put your question in the comment section below. Okay, and if you are also finding this valuable, please put that in the comment section, because as you comment about this video, then YouTube algorithm might be able to rank us higher. And also click that like button, that also helps us with the YouTube algorithm. Okay, now very good guys, now that we have gotten our data frame, this is what we are interested in. We don't want to do any more transformation. Now, according to our schematics that we had, our architecture, we have finished our transformation. Now we want to load it back into S3 bucket. Okay, we want to save it into S3 bucket so we can have this. So we want to write the final data frame into an S3 bucket. We want to do it as a package file this time around. Okay, so what we can do is that we can say this is our S3 bucket, right? We give it a variable name. So we have this. Remember that we had created the S3 bucket previously. Let's go back there. This Redfin transform zone YML. So that is what I am putting right here. Okay, and then I want to give the file that is going to be generated a name. So I'm giving it Redfin underscore data underscore package. Okay, I need to give it a name. So now I'll come to my data frame dot write. Okay, dot mode. What mode do I want? I want it to overwrite. If there's any file in there already, I want it to overwrite it. Okay, you could also have append, so depending on whichever one that you want. Okay, but in this case I want to overwrite. Then I'll say dot package, then goes into this S3 bucket. Remember, we have already said this S3 bucket is this full path right here, so we'll give this right here. Let's go first of all to our S3 bucket. Let's be sure that we don't have anything right there. So if I click on this, you can see if I refresh, there is nothing right here. Okay, so now let us run this cell. So this is going to take a few seconds, I believe, to run, and then is going to populate in our S3 bucket. Let's give it some time to run. Or better still, I can pause the video and then come back to it when it finished running. Okay. All right, guys, see you later. Very good, guys. Now you guys can see that this has finished running. Very good. Now let us go to our S3 bucket to verify if it has finished, if it indeed was able to load into our S3 bucket. Let us go to this tab. You can see previously, like we showed, there was nothing inside this S3 bucket. Now let us refresh this. Very good. Now you can see Redfin underscore data underscore parquet. Now we have been able to show that this is a success. Okay. Again, what did we do, guys? We were able to provision our Amazon EMR, right? And then we connected it to our Redfin source data, and then we got those files. We put that in our S3 bucket. Okay, we had an S3 bucket for that, and then we grabbed the data back again inside our EMR using Jupyter Notebook and Pyspark code to then do some transformation. We checked the data, we did some fill, checking on the number of rows, dropping NA and all of that. And then the resulting data, we write it as a parquet file inside our S3 bucket back again. Very good, guys. And also one other thing I wanted to show you also is that, remember that when we created our studio and our workspace, we also created a bucket where we said that the Jupyter Notebook by default is going to be saved by the AWS. Okay, so if we click on this, you can see this is where our Jupyter Notebook is created. You can see Redfin EMR workspace.ipynb. You can see that right there. Okay, that means that you can download this and share with anybody and all of that. You can see. So guys, we have been able to run this project. Yes, it was a long journey, but it's really worth it. Okay, we have been able to learn how to use Amazon EMR to perform extraction and transformation of Redfin data. You can also use this in any different kinds of data. Okay, and also in the next video, what I think we can then do is that we can automate this process. As you can see, everything that we did right here was all manual. And the reason I did it first was to show you guys how we provision Amazon EMR and how we can be able to connect to the Redfin source using the wget command, the bash command, and also be able to use Pyspark to do transformation and then to be able to interact with our S3 bucket. Now we know how to do it manually. Okay, but what about if we want to automate this process using Airflow? Okay, and that is what we are going to be doing in the next video. We are going to be using Airflow to automate all these processes, and then we are going to connect the resulting data to Snowflake. Okay, so that means that when the data gets into our S3 bucket as a parquet file, we want to load it into Snowflake. Previously, I showed you in this video right here how you can automate uploading a CSV file into a Snowflake table. Okay, but in the next video is going to be a parquet, just like as you can see that this time around we generated a parquet file in our Transform S3 bucket. Okay, so now when we get this, we want to be able to automatically load it into a Snowflake table. Okay, how do we use Airflow to be able to automate all this process? Basically, the extraction, the transformation, and the loading onto Snowflake table. All that we are going to be exploring in our next video. Stay tuned, guys. Again, if you have not subscribed, go ahead and subscribe right now. Click on the like button so that we can be ranked higher by the YouTube algorithm, and put your comment in the description. Put your comment in the comment section below. And also, when you are done with this project, do not forget to delete all the necessary things that you have provisioned, such as your Jupyter notebook, your workspace. You need to stop and delete the workspace, delete your studio, delete your S3 bucket, terminate your EMR. Okay, terminate your EMR. Although if you don't terminate it, it's going to terminate itself based on that date or time that you put for it to terminate automatically. But if you are done before that time, it's better for you to just terminate it yourself. Okay, you can also delete your VPC and the service role, the instant profile role that we had created, all the different things that you have used on during this project, so that you don't get charged for this. Take for example, even the user that you created. Although you're not going to be charged for that, but if you don't need it anymore, you can just remove that user. Okay, very good, guys. Very good, guys. Very good, guys. And again, take note that all this code that we have used right here, this Jupyter notebook, make sure you save it and download it so that you can put on your GitHub. Okay, so that you can use it as part of your portfolio. Okay, in my own case, I'm also going to have saved it right now, and I'm also going to download it and put it in my GitHub, so that if any of you want to fork it or you want to download it, you can download it and then use it for when you are running this project. Okay, and every other link that I've used in this project, such as this Redfin link, and then where I explained this EMR, I'm going to be giving you all this in the description below. Okay, guys, please help to share this video among your friends. Okay, please share this video among your friends, among your family, among your teammates, your colleagues. Okay, and please encourage them to subscribe so that they can learn more about these data engineering things from our website. Okay, from our YouTube channel. And also very soon we are going to start exploring Azure Cloud. Okay, we're going to be reproducing some of the projects that we have done previously, but then we are going to be using Azure Cloud to execute those projects. All right, guys, I will see you in the next video. Bye.